Hello students, welcome back. Now we are going to be talking about scalars and vectors. So what exactly is a scalar? Well, it's a quantity that only has magnitude. In other words, it has a value. It has no direction. So it's just a number. That's all it is. For example, 10 kilogram. You do not say 10 kilogram has a direction. You don't say east, west, south, or up or down. You just say 10 kilogram. 25 degrees Celsius. It has only a magnitude. It only has a number, a value. It has no direction. 5 seconds. Rupees 1000, dollar 342. All of these numbers, they only have magnitude. All have size and value in you. In other words, they have no direction. That's what makes them a scalar quantity. A vector, on the other hand, is a quantity that has both. It has magnitude, it has a direction. Magnitude tells you how much, in other words, size or the length of that vector. Direction, this tells you where it is going. So, for example, if a car it moves at 60 kilometer per hour or 60 miles per hour, that would be your magnitude. If it's going in the east direction, so it's telling you a direction, east. So this makes it a vector. So with 60 kilometer per hour and east, both the information combined together, that's what makes it a vector. Another example of a vector would be something like this. Let's say this is an arrow right here. So the length of this arrow, this would be your magnitude, and the direction is in this direction right here. So that's what makes it a vector. This is a vector. This is a vector. This is another vector right here. This vector could represent the speed of a car. Sorry, the velocity of a car. So 60 kilometer per hour, that is the magnitude from here to here, and the direction is in the east direction right here. So the basic idea is this. A scalar is just a number. A vector, on the other hand, is a number plus a direction. So the direction is what makes it a scalar turn into a vector. So mathematically, we often write vector with this notation like this. So we have a letter. Okay, it could be A, B, C, D, could be any letter, and then we put an arrow on top, and then we say equal to x comma y. So in this case, you have two components. You have x and y component. By the way, you can have 3, 4, 5. You can have many components. For example, if I say vector v equal to 3, 4, it means that move 3 unit in the x direction. So you go 3 unit in this direction right here, and then 4 unit, move 4 unit in the y direction. So you go 4 unit in this direction, and then you're going to reach this position. So your vector now is from here to here. This is your vector. So this 3, 4 vector would be this one right here. In machine learning, a vector is a list. In other words, an ordered collection of numbers that represents your data. So suppose you have vector A and vector B. Vector A is 2, 3, 5, and vector B is 3, 2, 5. The numbers, if you look at it, they're pretty much, the numbers are same, but they're ordered different. So because they're ordered different, my A and B, they're different vectors. Now, vectors are used to represent features of a data point. So let's understand this through some examples. Let's take a look at an example of a 2D vector. Suppose you have a day data. So let's say the temperature is 30 degrees Celsius and humidity is 40%. So your vector is going to be 30 comma 40. Your 30, this will be temperature, and 40 will represent the humidity. Let's take a look at another example. Patient data. This would be a 3D vector. So let's say you have a height of a patient 170 centimeter, weight is 75 kilogram, and age is 30 years. So in this case, my vector is going to be 170 comma 65 comma 30. Another example, a student data. So let's say a student, his age is 17, he studies for 3 hours and his percentage is 78%. So his data, his vector would be something like this: 17, 3, and 78. 5D vector, a patient data maybe. Glucose, BMI, BP, age, skin. Let's say these are the corresponding number right here. So this is another vector right here. Then you have word embeddings in natural language processing. So for example, the word king, maybe it could be represented by a vector like this: 0.21 comma minus 0.34 comma, and then some bunch of numbers over there. Now let's understand this 3D vector. A student data. So age is 17, study hours is 3, percentage is 78%. So this vector would be 17, 3, 78. This particular vector, this describes one student, and each value, this value, this value, this value, each one of these values, they are called features. So in this particular instance, I have three features. I have an age feature. This is my age. Then I have study hours features. This is my study hour right here. And then I have percentage feature. This is my percentage, like how much he scored. So vectors, they are feature representation. Now let's take a look at another example. Text to vector. This is a very important concept in machine learning. Your machines, they cannot read words like we humans can, like you and me, we can. Suppose you have a sentence, and the sentence is, I understand data science. This is a simple sentence that you and I can understand, but machine cannot understand that. So what we do, we convert that into these vectors right here. So this is a vector. And the process the process of converting this sentence into vectors, it is called, sometimes it's called feature encoding. It could be embedding, or it could be called vectorization. Now your vector may look something like this: 0. 0.2, 0. 0.8, 0. 0.6, 0. 0.1, comma, and maybe other bunch of numbers over here. Now your data set can be thought of as a collection of vectors. So suppose your data set looks like this. You have an age of someone, 22, his salary is 30,000, his experience is 1. Then you have another guy, this is his data right here. This is third guy, that's his data. So I can represent this data through vectors. So this data right here, this first one, can be represented like this: 22, comma 30,000, comma 1. This one. Then this data right here, this can be represented with this vector right here: 35, comma 70,000, comma 10 right here. And then the third vector, the third data, can be represented with this vector: 52, 56,000, and 9. That's these numbers right here. So each row can be thought of as a feature vector. Image can also be represented as a vector. An image is nothing but just pixels. Suppose you have an image like this. The size of this image is 8 pixel by 8 pixel. You have 8 pixel in this direction. 1, 2, 3, 4, 5, 6, 7, 8 pixels. And then you have 8 pixel over here. 1, 2, 3, 4, 5, 6, 7, 8. Now, each image in this case is basically 64 pixels, because 8 in this direction, 8 in this direction, total would be 64 pixels. Now, the value on these pixels, they range from 0 to 16. When you see a number 0, it means that there is no color. It's black, pitch black. But if you see a number, let's say 16, that means it's white. So anything in between, that will be going from black to white. So let's look at this number. This is 0. This is 5. And you can see that's kind of like grayish. This is 13. It's a little bit more white. This is 9. It becomes less. This is 1, which is almost close to 0. So this is almost like black. This is 0 and 0. Now, I can represent this image through a vector. And this is the representation of this vector. So 0, 0, 5, 13, 9. You can see that 0, 0, 5, 13, 9. And then it goes 1, 0, 0, 1, 0, 0. So this is my first row right here. And then it starts with 0, 0, 13. And this number right here, which is 15, 0, 0, 13, 15. Then it goes 10. And then it goes, sorry, is this 10? Yeah, this is 10. And then it goes 10 and then 15 and then 5 and 0, and then 10, 15, 5, and 0. And then it's keep going like this. So basically, this particular vector, this one has 64 different numbers. 1, 2, 3, 4, all the way up to here is 64. So this is a representation of this image right here. Let's take a look at another example. This is a digit 4. You can see that it has an outline of digit 4. Now this digit 4 contains these pixel values. So this particular vector, it represents digit 4: 0, 0, 0, 1, 0, 0, 0, 1, 11, 0, 0, 0. You can see that 11, 0, 0, and so on and so forth. Previous one, if you look at this number, this was almost like a 0. Actually, this is, if you look at the image, it looks like a 0. So this particular vector represents digit 0. Another example of vectors is in neural network. Here you have layers. You have layer 1, layer 2, layer 3, you have multiple layers. So each layer, it transforms an input vector into another vector. So let's say a vector comes over here. This is my vector right here. This vector comes into this layer, and this layer is going to take this vector and it's going to transform to another vector. Then this layer is going to take those vectors, it's going to transform into another vector, another set of vectors. And this process will keep going until towards the end. And now let's take a look at the magnitude of a vector. Suppose you have a vector in two dimension like this, a equal to 3 comma 4. It means that you go 3 unit in this direction in horizontal direction and 4 unit in the vertical direction. Now if you remember from a high school Pythagorean theorem, the length of this vector from here to here, that would be equal to 3 square under root of 3 square plus 4 square. Now the magnitude of this can be represented through this notation right here. So I'm saying vector A, you go like this and put this little parallel lines around it, or you can just say equal to A. This is exactly what I'm doing over here. So this is equal to square root of 3 square plus 4 square, and the answer will come out to be 5. Now, this idea can be extended to higher dimensions, to 3, 4, 5, 6 dimensions. So suppose you have a vector 2, 3, 5, 7. You want to calculate the magnitude of this vector. The magnitude would be equal to your 2 square plus 3 square plus 3 square plus 5 square plus 5 square plus 7 square plus 7 square. And calculate that. That will give you the magnitude of this vector. And now back to scalar again. So scalar, think of that as a number that can scale up or down a vector or any measurable quantity. So suppose you have a vector like this, and I multiply this by 2. This is the scalar right here. If you multiply this by 2, every single number is going to get multiplied by 2. So 2 times 170 is 340. 2 times 65 is 130. 2 times 30 is 60. So what just happened? This scales up everything by factor of 2. This right here. If I say 0.5 times the same vector, so in this case this is my scalar 0.5 and this is the vector, so it's gonna half everything. So 0.5 times 170 is 85, 0.5 times 65 is 32.5, and 0.5 times 30 is 15. So this scaled down all the values by half. So why vectors are important in machine learning? Well, machine learning, it works by comparing vectors. For example, there are models that computes distance between vectors. So suppose you have a vector A and you have a vector B and you want to calculate the distance between these two vectors. So it is going to use 1 minus 1 square plus 3 minus 5 square plus 5 minus 2 square and then square root the whole thing. That will give you the distance between these 2 points. So there are algorithms that needs that distance. Sometimes some models they need to compute the angle between the vectors. Sometimes they have to find similarity between the vectors. So that's why vectors are important. Some of the examples would be your recommendation system, face recognition, chat GPT embeddings, search engine. All these systems they use vectors.